Hello everyone, myself Mrityunjay. I am pursuing my Masters in Physics from IIT ISM Dhanbad. So today I will explaining about circular motion. So let's start with the topic. So what is circular motion? So see, if an object or a particle, let's suppose its mass is m. So if an object is rotating about a fixed point, we call it a fixed point as a center. If an object is rotating about a fixed point, maintaining a certain distance, so this type of motion of the particle is referred to as a circular motion. So how many ways in a particle can rotate about this point? So obviously there are only two ways. So if particle is traversing like this, so this type of motion is clockwise circular motion. Or another one is, it's opposite. If particle is traversing like this, so this is anti-clockwise circular motion. Anti-clockwise circular motion. So let's see. If we want to explain circular motion in detail, so we have to use some terminology. As we have used earlier in kinematics, so we have used their displacement, velocity, acceleration. So in a similar manner, we will use here angular terms. So let's start with the term point by point. First one is, what is angular displacement? I am listing points and I will explain one by one. Angular displacement. First one is this. Second one is angular velocity. And third one is angular acceleration. Acceleration. So let's start with angular displacement. Suppose particle is rotating like this, and it is initially at this point P, and after some time it is at point Q. So what is angular displacement? Let's say I am saying displacement, and that displacement is an angular displacement. So I am talking about the change in its angle. So what we know, that angle equal to arc length upon the radius. Arc length upon the radius. Suppose this length is L and radius of the path is R. So here theta will be L by R. This is angular displacement. Now let's move to angular velocity. So what is angular velocity? As we know that linear velocity is rate of change of displacement with respect to time. So seen in a similar manner, angular displacement is nothing but, angular velocity is nothing but the rate of change of angular displacement with respect to time is called angular velocity. So one thing I forgot to mention, that dimension. The dimension of angular displacement is radian. It is unit, and its dimension is, it has no dimension, so it is dimensionless quantity. Here omega, angular velocity. Angular velocity has a unit, radian per second. So its dimension will be t to the power -1. Now let's come to angular acceleration. What is angular acceleration? So angular acceleration, alpha, we denote it by alpha. Alpha is rate of change of angular velocity. So its unit will be radian per second square, and its dimension will be t to the power -1. This is some general information about angular velocity, angular displacement, and angular acceleration. So let's move to the next point. In this point we will discussing about how to find the direction of angular displacement, angular velocity, and angular acceleration. So let's suppose we have some arbitrary motion. This is circular motion. Particle is rotating like this. So if you want to find the direction of angular displacement, so we will use here right hand thumb rule. What we will use? We will use right hand thumb rule. You may use different type of rules, but I am referring here right hand thumb rule. So what does this rule say? If our fingers are denoting direction of motion, then our thumb will denote the direction of theta. So let's try to understand from here. We can say in this picture, if you want to align our fingers in the direction of motion, so it is like this. Our finger is curling like this, and our thumb is pointing outward the board. So here the theta will be like this. along the axis of rotation. It is a very important point. And another one, if our object is rotating like this, so what we will do? Again we will try to curl our fingers. So if I am curling my fingers like this, then it is, my thumb is going downwards to the board. So here theta, direction of theta will be like this. Now let's move to next point. We will again discuss in brief what is average angular velocity and average angular acceleration. Average angular velocity. Average angular velocity. So average angular velocity, this is the total angular displacement divided by time. Suppose what I mean to say, or we can also say that total angle traveled upon total time. So let's say our object is moving like this, initially this and this, there is some angle theta. It's a general notation. So suppose at later time it is at theta 2 angle subtending, and initially it was subtending angle theta 1, and time difference in doing so this is average angular velocity. So this will be the average angular velocity. In a similar manner, what will be the average angular acceleration? Average angular acceleration. Average angular acceleration. So just like what we have done in finding angular velocity, we subtracted total angle travels minus total time. So here we will say total change in velocity, angular velocity divided by total time. Suppose at time t1 angular velocity of particle was this, and after at time t2 the angular velocity was this. So we will subtract omega 2 minus omega 1 upon t2 minus t1. So this will give us our average angular acceleration. So now let's move to the next point. I am going to discuss what is retardation. So retardation is nothing, just suppose if particle is moving, I am putting some external thing which is stopping the particle. I am just, if you say in Hindi, retardation is rukna. So what is retardation? So let's try to relate this with kinematics. If our particle is moving in linearly like this, so if I put an external acceleration in opposite direction, then it is also applying retardation. But if our particle is moving like this in negative x direction, and I am putting acceleration in this direction, so it is also retardation. There is a very big misconception of retardation, that it is only negative, acceleration negative, it means that retardation. But no, retardation doesn't mean that acceleration is negative. Retardation actually means that opposite to the velocity. Retardation is always opposite to the velocity. So it's kinematics thing. Now let's jump to our circular motion thing. So suppose our particle is moving like this, and this, and it is direction of theta is like this. So if you want to speed up, if you want to increase the velocity, then omega will be with this, and if you want to decrease, omega will be opposite to this. So this may be understood. So now let's move to the next topic. What is tangential acceleration? And now I am starting the main thing of the circular motion. Suppose particle is generally moving like this. Now what is circular motion? If particle is moving in a circular path, then there must be some force which is making particle forced to move in the circular path. So in circular motion, there will always be a force towards the center. So tangential acceleration and centripetal acceleration. So centripetal acceleration will direct towards the center. So what with this centripetal acceleration will do? Centripetal acceleration always tries to change the direction of a particle. But what does tangential acceleration do? Tangential acceleration always changes the magnitude of the motion. Tangential acceleration always changes the magnitude of the motion. So what is the, now come to the point, formula. What is the formula for tangential acceleration and centripetal acceleration? So let me draw some nice figure. So this is some circular motion performing. So this point velocity like this, or this point velocity like this point tangential acceleration, this. So centripetal acceleration will be always like this, AC. So what is the formula for tangential acceleration? So what is the formula for centripetal acceleration? Sorry. So this will be AC equals to V square by R. AC equals to V square by R. This is our formula for centripetal acceleration. And what is the formula for our tangential acceleration? Tangential acceleration, this will be alpha cross R. Alpha cross R. This is the formula for tangential acceleration. So now we will study type of circular motion. So mostly there are two types of circular motion. First one is uniform circular motion and second one is non-uniform circular motion. As the name suggests, uniform circular motion. So here the omega will be constant. So what we mean by omega? Omega is our angular velocity. So angular velocity will be constant. So let's see. And also here the magnitude of tangential velocity will also be constant. So let try to see this by figure. Suppose the particle is moving. Here it is, speed is 10 meter per second. Here also speed is 10 meter per second. Velocity, here also velocity is 10 meter per second, and here also 10 meter per second. So we can see that its magnitude is constant, but its direction is changing. Its direction is, here the direction is like this, here like this, but the magnitude is always constant. So this is uniform circular motion. And one thing, in any type of circular motion, the centripetal acceleration will always exist. So AC will be always there. AC will be always there. So now let's come to non-uniform circular motion. So in non-uniform circular motion, there will be two cases. One case will be speed up and other case will be slow down. So what I mean by speed up and slow down? Suppose we start our fan. So initially the fan starts slowly, and after time it's constant acceleration. So this is the case of speed up. And when we switch off the fan, so it will decrease, and it will be the case of slow down. So here I will make two figures. Suppose here velocity is 10 meter per second, here 20, here 24, and here let's say 30. Suppose here velocity is 20 meter per second, here 18 meter per second, here 10 meter per second, and here 5 meter per second. So what I see? I am seeing that the velocity, magnitude of velocity is increasing in this case. So the tangential acceleration will, in this case, will be like this. It will support the motion. It will support the motion to increase the velocity. But in this case, the direction of tangential acceleration will be like this. It will be opposing to decrease the speed. So, but centripetal acceleration always be there. Always be there. Centripetal acceleration will always be there. But in this case, in uniform circular motion, AT will be equals to 0 and AC will not equals to 0. So here I have also AT and AC. So there will be a net acceleration. So how we will find the net acceleration? The net acceleration will be under root AT square plus AC square. So I will be discussing one example for this case. So let's try to solve the question. Suppose we have provided that angular velocity is like 2t square plus 1, and we have and it is following the path which has radius equals to 1 meter, and at time t equals to 1 second, we have to find the angle between net acceleration and centripetal acceleration. So how we will deal with this question? First of all, we have provided omega, angular velocity. So we have to find centripetal acceleration and net. So I will find that. We know that AC equals to V square by R, या फिर R omega square. So omega at t equals to 1 will be 2 into 1 square plus 1. So it is 3. So here AC will be 1 into 3 square. So it is 9. And AT will be R into alpha. So we know alpha equals to d omega by dt. So d omega by dt at t equals to 1. So what will be this value? It will be 240. Differentiation will be 40. So at t equals to 1, this will give the value equals to 4. So our AT comes out to be 1 into 4, that is 4. So as I know that centripetal acceleration will be like this, tangential acceleration will be like this, so its resultant A net will like this. So what is the angle between A net and AC? So this angle will be tan inverse magnitude of AT upon AC. So theta equals to tan inverse 4 upon 9. This will be the answer. So now I will discuss some important case of circular motion, which is very useful and usually asked in examinations. So let's see. First of all, we will try to resolve the forces, circular dynamics. If a particle is moving in circular motion, so how we will resolve the forces? So there are some points which we have to learn. First, we will draw the FBD. We will draw FBD. Second thing, we will try to resolve force along tangential direction and radial direction. So let's try to understand this with an example. Suppose we have a pendulum attached to the here, and it is also connected to this wall, and it is now here it is in equilibrium position. So let's say it is a position number 1. If I cut the point from here, so what will happen? This will reach at some point, and after going to certain distance it will come return. So here when it is at rest, so suppose here tension is T1 and here tension is T2. So I have to find what is the ratio of T1 upon T2. So what we can do? In first case, we can see that if this angle is theta, so if I will resolve this separately, so this angle is also theta. So the component of T1 will be T1 cos theta, and here what mg will be directed downwards, and this will be T1 sin theta. So what we can find that T1 cos theta is equals to mg. But in second case, the particle is here at rest, so it is not in here it is rest, but if the mg is acting downwards and this angle will be theta, I am writing down separately. Mg is writing downwards and this angle is theta. So it is performing circular motion, so it will try to come back in this way. So what will be the force which help the particle to bring back? So if it is T2, I will resolve the component of mg. So this will be mg cos theta, and this will be mg sin theta. So this, we can see this in this direction. So T2 minus mg cos theta, T2 minus mg cos theta will be responsible for centripetal acceleration, mv square by r. So here what we can say that at this position our velocity is 0. So m by r 0 ka square. So this will be T2 equals to mg cos theta. So let's see. This was from equation number 1, and after resolving second equation, what we get? We get that T2 equals to mg cos theta. So गलत हो गया यार, ऐसे सॉल्व नहीं होगा, पूरा वीडियो मेरा गलत हो गया. So what will be the ratio of T1 upon T2? That will be mg upon cos theta and mg cos theta. So mg and mg cancel out. So what we will get? T1 upon T2 equals to secant square theta. So this is a very normal problem in circular motion. So let's try to see some other cases in which these things follow circular motion. So let's see the case of conical pendulum. Let's see the case of conical pendulum. So what is conical pendulum? The normal pendulum moves like this. But what about conical pendulum? Conical pendulum will perform its motion like this, in this way. So let's try to make the figure. And it will rotate like this. Now, this mg is acting downwards. This tension is here. So here we have to also resolve the forces. If this angle is theta, so this angle will always be theta. So now here I will resolve the component of tension. So what you can see that this, in this direction the component will be t cos theta, and this direction this component will be t sin theta. So this is t sin theta is acting towards center. So this will be equated by centripetal acceleration. What is that? mv square by r. And this t cos theta is balancing mg. So what will be this? T cos theta equals to mg. Now be very careful. Here r is not L. What is the radius? Here the radius is r equals to L sin theta. So now again what we can find that, let's see theta. What is the angle theta? So if we divide, then it will be tan theta equals to mv square divided by r divided by mg. M to m cancel out. So here v square will be, after putting the value of r, L sin theta, Lg gl sin theta. So what we can do? Tan theta equals to v square upon gl sin theta. So this is a simple relation. We can use this relation to find out the omega and also the time period. So this relation will be helpful. Now let's move to the next case, in which we will discuss bending of cyclist, the motion of cyclist. Suppose it is a bending of a road, and one cyclist is moving and he has to bend on this road. So what we will do? Usually the weight of the cyclist will act downwards. So to move in this direction, perform, it is like circular motion. So to perform like the circular motion, it normal has to bend. So if it is n, so the breakdown of component of normal will be n cos theta, and this will be n sin theta. So again breaking down, the n cos theta equals to mg and n sin theta equals to v square by r n. So what will be that? So if we will divide, tan theta equals to v square by divided by rg. So these are the simple cases which we can understood here. So it is all for today. So what we have understood in this lecture, initially we started with the definition of circular motion. We studied angular acceleration, angular displacement, angular velocity. After that I taught you about the retardation terms, and after that we discussed uniform and non-uniform circular motion. From bringing that, I discussed some example of like bending of cyclist and the conical pendulum, and that was the example of the normal pendulum. So these are the some basic topics for circular motion. I hope that you enjoy the videos today. Thank you all.